Hi, welcome to our new video. In this video, we are going to discuss about the DNS for the services and pod inside the Kubernetes. We have discussed about this in our last session, and this video is in continuation to our last session where we discussed about the services that we create inside the Kubernetes, how we can call those services, how the DNS name is being assigned to those services by the Kubernetes when you create the services inside the Kubernetes cluster. Now, the pods that we are creating inside the Kubernetes are also assigned a DNS name. So this we have already discussed in our last part. So if you haven't seen that part yet, I would suggest you to first go through that part and then continue on this video. Now, if we come down to the services, so basically there are two types of services, which is a normal service and a headless service inside the Kubernetes. Now, and there are various records which are associated with these services, which means that there is an A record and a quad A record, as we call it. Now, A record simply resolves the domain name to an IP, while if you are on IPv6 address, in that case the quad A record is going to resolve your DNS name. Now, based on whether which IP type you are using, whether it's an IPv4 or IPv6, the A or the quad A record is going to come into picture and it's going to resolve the DNS name. In case of a normal service, the name of the DNS will be your service name followed by your followed by the namespace followed by svc.cluster-domain.example. So this is going to resolve to the IP of the service. Now, when it resolves to the IP of the service and this name is fixed based on your service name and the namespace, you don't have to actually log in inside the Kubernetes and get your service IP each time. So you can directly specify the service name so that if my services have to communicate inside the Kubernetes, then it can use this domain name, which will get automatically resolved to whatever IP that is being assigned to the within the cluster. Now, if in case this service gets deleted in future, then again, because the name of the service is same, or if we plan to create the service in some other Kubernetes environment like in our data center or cloud, then again whatever IP is assigned, we are not worried about that because we are going to call the service by its name. Then there is a second type of service, which is a headless service. What this means is that it will be without a cluster IP. So when we create a service, we can have the cluster IP for the internal communication, but if you do not create a cluster IP, it's without the cluster IP, then also you can communicate between the services with the headless. In this case, the name of the service would be again my service.namespace.svc.cluster-domain.example. But unlike the normal service, the service name in this case is going to resolve directly to the IPs of the pod selected by the service. Now, remember that this IP can change based on the round robin algorithm which is followed inside the Kubernetes. So it is possible that every time I resolve the service, I am getting a different IP address because the pods, the service itself is resolving them on the basis of round robin. So the IP is continuously changing. So but then the request will directly be going to the pods and they will be serving the request. This type is known as the headless service. Okay, now let's come down to the SRV records. Now, what are SRV records? SRV records are basically created for the named ports and they are a part of your headless service. Now, for each named port, the SRV port would have been assigned. Now, what is this SRV port? So basically the port that you have specified and where the port forwarding is taking place, it will start with my port name, whatever underscore my hyphen port hyphen name, basically the port name that you have specified for your service, on which protocol it's going to work, whether it's TCP. Okay, so that protocol, my hyphen port hyphen protocol dot my hyphen service dot my hyphen namespace. So basically the port followed by the protocol that you are using, followed by the service name, followed by the namespace, then svc.cluster-domain.example. So this is how you can use the SRV records to map the port number. In that case, you will not have to specify the port number. In that case, you can directly map it as in the form of a DNS name, and you can directly send out the request. Now for a headless service, this resolves to multiple answers, one for each pod that is backing the service, because it is possible that we are having more than one container inside the pod. So again, each pod which is backing the service and contains the port numbers, and the domain name of the port will be auto generated, name -my -service .my -namespace .svc.cluster-domain.example. So this will be the SRV records that we are going to use for the port number mapping. Now same records are same record of A and AAA pod A records are also applicable in case of the pods as well. So if we talk about the pods, the name of the DNS name of the pod will be slightly different than the naming convention that we followed in the service. So in case of the pods, the name would be assigned in the form of a pod IP address followed by the namespace in which the pod has been created. If you do not assign the namespace, it will auto by default going to resolve to the current namespace in which you are working. And then because the pod will also be created inside that namespace when you basically the default namespace, but then the name would be pod-IP address dot my -namespace in which the pod has been created .pod.cluster, okay, -domain.example. So basically it's identifying the pod, the namespace .pod.cluster, okay, -domain.example, whatever domain that you are using. So suppose if you launch it inside a default namespace with an IP, let's say it can be any random IP 172.17.0.4, then it will be like 172.17.0.4 dot default is your default namespace .pod.cluster.local. Okay, so this is how the records will be resolved in the domain name will be resolved in case of the pods. Okay, now next we are going to look at this practically. So what we are going to do is we are going to create a service. We are going to see its the DNS record which is being created for that service. At the same time, we will also be creating a pods and we will check out for that. So in the later part, we are going to check it practically by running it on the Kubernetes cluster. Alright, thanks everyone. That's all for this video. If you like it, please comment if you have some doubts, and do subscribe to our channel. Thank you everyone.